Hello, colleagues, and thank you to the previous presenters who were able to actually dive into very interesting topics, and the last one was very much similar to our latest concept of the synergy between cloud and the intelligent edge computing. My topic will be more focused on data centers, and I will talk about how we use AI in our internal networks for our data centers. It's well known in Asia, but for Russia it's quite new, and to give you an idea of why those technologies are being used, let me give you a landscape of where it's been, what's going on in the data centers. Depending on the customer maturity, this process can be about basic procedures or data center consolidation that is currently encompassing a lot of customers both in Russia and in Asia. And you will see that despite we have a number of different recipes, the goal is the same: to maximize the applications, to simplify the usage of such solutions, and this approach depends very significantly on what the end customer would like to get. If we look at other markets, you will see those hybrid clouds in huge demand, and Russia is just approaching this moment in time. Maybe we will miss some of those steps and start using AI in the data centers on a very mature stage. Many of you would know Huawei as the ICT provider, some as the owner of big enterprise with our traditional projects like servers, networks, and data storage systems. But besides that, we invest a lot of effort, both in our home country and in Russia, into the projects using AI. If you look at the products described, they all have some part of AI integrated. A breakthrough here is that the company would use its products and its know-how in all of the solutions. If we talk about the data centers, then and of course most mature customers will be here, then we can provide all the technologies with inbuilt trained AI systems. MPU, Atlas, the models that previous speakers talked about, our development stack like Model Arts are already covered in the previous presentations. So my presentation will be showing you the infrastructure for those applications. So we all have a choice of whether we perform an evolution or a revolution. And the scope of the storage transformation, for example, those cuts are developing in huge strides. In terms of the calculations, we have a huge amount of options in the heterogeneous infrastructure. Beside the central processor architectures, we have AI chips, graphics processing units, and other things that are specialized. Hard disk drives have evolved from spindle design to SSDs, and at some point in time, the network was so-called, younger brother. It was not developing as fast as the computing or storage, but despite that, the networks within the data centers were mostly using either fiber channel or Ethernet. They both had their advantages and disadvantages, And at some moment, we saw that the classical network solutions are not sufficient to perform well in the AI and heavy data storage scenarios. We have introduced NVMe over Fabric scenarios, and for each architecture, we got our own scenario. One of the most effective ones was to use the Ethernet stack, but with some improvements. Let us talk a little bit about the what was happening previously. The storage landscape is changing. Look at your home environment. Look at your work environment. People who are already some time in the industry, they remember the 525 floppy disks. I even remember AD bus 30 megabyte drives, ID bus 30 megabyte drives. And currently you can have the amount of memory in your phone that is much bigger than 10 years ago was available for the top computer. The amount of calculations performed by a modern phone enable us to change the scenario and paradigm of its usage. So we don't have an industry revolution 4.0. We now have an industrial revolution 4.5. Because with the storage landscape, we obviously have, same as with planes, another paradigm shift. So as we are a vendor having a lot to do with AI, we have created the data centers of a next generation. It's a flash era data centers when we use those flash drives as the main core component of our infrastructure. And then, besides having a million IOPS that is promised by many vendors, is another important characteristic is the throughput delay of less than 0.1 millisecond. To achieve that, we use a lot of technologies that I will be mentioning further on, but unfortunately, as we only have 15 minutes, I will have to stop on each and on only the most important ones. To build such a network without losses, or if we build such network without losses, we can improve even the current infrastructure performance by up to 2 times and reduce the latency by roughly 18%. With that, you can optimize the TCO and get an average performance of, as I said, 18%. And the pilots we ran in Russia to apply those technologies show that by 2021 we will be able to join the industrial, to launch some industrial projects. Unfortunately, the Black Swan event of COVID has delayed these projects. Where do we see those technologies progressing? It is the networks that use static thresholds. They are not changed depending on what's going on within our network. We just define it once, and what happens will happen. We'll have to work with that threshold. This is not always convenient because the current paradigm of the data center is cloud, and cloud is very agile, is very flexible. There's no static loads, no static scenarios that we had in the data centers 10 or 15 years ago. You would need to use the new technologies that will enable you to work with thresholds in a more intellectual way. To achieve that, we use the same devices that my colleagues have mentioned. A SAN 310 chip integrated into our hub that would enable not only edge computing, but integration with our network architecture. Why is the fiber channel not sufficient? They worked based on the credit principle, and starting with the specification, the issue of allocating those credits was not solved intellectually, apart from manual setup. And of course, the modern fiber channel fabrics have made a breakthrough. And with autonomous storage networks, we've got only the new hardware working effectively, and it's not backwards compatible with the other storage systems. So, by using the intellectual Ethernet networks to build such solutions for, data aisles and for high load processing, and using the per-flow control technology and training the AI using explicit notifications, we can solve that issue. As you see, the network becomes not just a network, but also a place for AI models to be used. If you look at the cycle, you will be surprised to see we have our trading cycle and our inference cycle that is different, very different from a classic network. The classic engineers that work with data center solutions would usually operate on classic principles, and now with digital transformation and AI, the approach to the data centers is different. Let's look at the algorithms. AI ECN principle is very elegant and simple. Why so? It has a huge application examples library, and what is good for VDI is not very good for databases. By using the models accumulated, we can apply them to the traffic we are interested in. But as we see many customers developing their own applications, we can apply additional algorithms to optimize the network specifically for those applications. And then those models will be applied to our network devices. So the commercial chipset devices, like American vendors would produce, we will have to add the SAN 310. But if that's a hub made by us, then we can introduce that chip directly there. The amount of intellectual networks and the amount of models increases dramatically because we can do those intellectual chipsets. So how does the application model look? We have supervised learning, heuristical search for the machine state models, and we analyze the incoming traffic. For example, for some customers, the traffic will be a priority. Some types of traffic will be a priority, and we can let the customer choose his or her priorities and flexibly define, not for one hub, but for the whole network, what they would like to get. And if we cannot identify the application somehow, then we just launch the next step and define the influence, understand the min and max values depending on the traffic parameters. And on the right, you can see how it will look for the known applications and for unknown applications. Further on, the applications will be ranked, and based on that ranking, the model will be defined and finalized. But if that mechanism was not sufficient, we will be applying our last hope, the heuristical search algorithm. We will run a mathematical model, process all the values that we know. We know pretty much everything about the traffic that passes through our network. The network itself becomes the sensor and the AI model. So the hubs, they don't look into the data that passes, goes through them, but it understands all the network attributes. And those network attributes can affect the performance of our applications. What our experience shows is that if we get the increasing latency coefficients, say 10, 30, or 50%, this can change the training model, degrade the performance of the training model to zero. And of course that will be unpleasant for both the customer and the business process owner. If we go deeper, you will see our typical scenarios, how we work with our service models, how we can solve the performance issues, and how we can improve the application usage in our network. As my time is close to an end, I would like to say a couple of words. Those numbers you see are supported by the international TOLI consulting agency. You can feel them using the neural net training applications, different storage models, and HPC clusters. And all that is now transitioning to AI 2.0. AI 1.0 is implemented in the Chinese banks, Chinese operators, and has passed a number of quite successful deployments. So, interestingly enough, we can ensure the InfiniBand-like technologies. This allows the customer, besides optimizing the storage cost, to ensure he or she can choose a model that is independent of vendor lock-in. And the last thing I would like to mention is that the biggest economic impact you can get from the DCN and SDS. There we see up to 45% investment savings. Michael, hello? Hello, do you hear me? Yeah, I can hear you. So once again, you didn't hear me. So thank you indeed for a very interesting presentation. And this is a very new and very advanced topic. Modernizing data center networks is the most important thing, to my mind, of moving to the new age. So the question we got was, what is currently the biggest issue for a standard calculation architecture data center to move to the new AI-based data center? So what stops the data centers from transitioning to this new infrastructure? Well, I would not say it's a very good question because it's very trivial, but it's a crucial question. If we talk about the AI networks, then it's it's a mixed ball, and you see the networks and the data centers that work with AI differ significantly from standard loads. Like what we see with Vox 900, it's like 50 kilowatts of power for just one rack. And if we look at the overall picture, then we'll see that the modern data centers are not ready to work with high load applications. So my recommendation for that scenario would be to avoid a standard scenario, a standard approach of just building separately the building, then the network, then the equipment, and to use so-called horizontal architects that, instead of allowing you to just create an IT Frankenstein, to build a holistic system aimed at solving specific tasks. And currently we see this as the highest priority challenge that most of our customers face.